Yes, sir. Hello and welcome to the Technogate. In this session, I am going to solve the Telangana State EC 2021 paper, and we will try this paper for electronics engineering. So this is previous year, so you can check your concept. So with these questions, I will tell you the logic behind these questions, everything related to this question, so that you can make your concept clear. So let's start with the first question. What first question is saying, in an PN junction, the depletion region behave is. So for PN junction, if I draw a PN junction, I can say this is my PN junction. This is one PN junction, and let's say this is the contact point. This is P region. This is N region. So near the junction, immobile ions are there. Near the junction, there are immobile ions. What I can say, if something is P means holes. Holes is always associated with negative ions because hole will contribute in current. This ion will not contribute in current. This is free charge carrier, this is ion. And what is N-type charge carrier? It is positive ion and having extra electron. So near to the junction, there will be electrons and vacancy of electrons. If electrons and vacancy of electrons are there on the same potential, there will be a recombination. So you will get negative charge ions here and positive ions here. Correct? And this is known as width of depletion layer. This is known as width of depletion layer. As we know, this is the width of depletion layer. What I can say, as we know that ions do not participate in current conduction. That's why you can say this is not semiconductor, this is not conductor, this is not high resistance, because when you apply reverse bias, then this will become high resistance. This will act as a insulator. So which option is correct here? You can see B option is correct in this question. B option is correct. These ions will not participate in current conduction. What I can say, these ions will not participate in current conduction. I hope this is clear. Let's go to the next question. What next question says? Next question says that which of the following circuit used to add an DC voltage to its input? Means, what is the meaning of this question? Suppose I am having, what I am expecting? I am expecting this. If my VI is input to the circuit, maybe some sinusoidal waveform or square waveform or triangular waveform, what we want, maybe 2 volt plus VI, maybe minus 2 volt plus VI, maybe 5 volt plus VI, or any general number VI plus this input VI. And this action is known as clamping. Clamping means what? Clamping means to shift. What is meaning of clamping? Clamping means to shift something. So to shift AC waveform is known as clamping action. To shift the AC waveform is known as clamping action. So what do we need to shift a waveform from a DC voltage? We need a clamper. Clamper is the circuit which shift the DC waveform, and this is for your reference. I can draw the clamper. This is the clamper circuit. This is the clamper circuit. This type of circuits are known as clamper. This type of circuits are known as clamper, and if you take output across resistance, it is known as clamper, and when you take output across capacitor, it is known as peak detector. There are two names of this circuit. If output is taken across capacitor, it is known as peak detector. It is known as peak detector. If output is taken across capacitor, it is known as peak detector. Peak detector means a signal which detect the peak, maybe positive peak or negative peak. And one diode is there. And if output is taken across resistance, then it is known as resistance or diode. It is known as clamper, clamping action. There are remaining options. One option is rectifier. Rectifier is idea of converting AC to pulsating DC. So you can say this is idea of converting one AC signal into DC signal. Second is regulator. Regulator is the idea of maintaining a constant load voltage for fluctuation of input or for fluctuation of load. So this is idea of maintaining constant voltage across load. And third is clamper. Clamper means shifting. And clipper. Clipper is the idea in which we remove the unwanted portion of a waveform using diode. So this is clipping the unwanted portion, or idea of removing unwanted portion. The idea of removing unwanted part of the waveform is known as clamping action. So I hope clipping action. So I know you have understood what is the meaning of clamper. Means you can have this type of output, or you can have this V plus minus Vm. And this clamper which I have drawn here is known as unbiased clamper. There are biased clamper also. This is Vi. And this Vi, this value is what? V maximum value. Plus minus of V maximum value. I hope this is clear. Let's go to the next option. What it says that JFET, junction field effect transistor, has high input impedance. Why any semiconductor device will show the high resistance? The idea is any semiconductor device will show high resistance only because that junction is reverse bias. So without any second thought, you can correct on this option. Okay. Next. What next question say? In rectifier, the large value of shunt capacitor. In rectifier, what is rectifier? The first rectifier is this. First rectifier is idea of converting AC into pulsating DC. And from pulsating DC to DC, we need one capacitor. Means this is the rectifier. Let's say, let me draw any of the rectifier, popular rectifiers. This is your rectifier. the idea of converting AC into pulsating DC. And now we are having one capacitor. The question is about this capacitor. So can I say the current across capacitor is IC equal to dV divided by dt. So higher value of capacitor means larger current. This is the idea. Next question. Which of the following major drawbacks of voltage regulator as compared to shunt voltage regulator? Okay. So when you go to this, what is a major drawback? This is the theory based question. So what I can say, additional circuitry is required means in shunt regulator. So B option is correct. Remaining, because this is the theory problem. There is nothing dependent on some calculation, not dependent on calculation. Okay, the next question. Next question is related to BJT. And what this question says? This question says the condition for transistor to be in saturation. Suppose I want my bipolar junction transistor BJT in saturation. So BJT in saturation, I want emitter based junction as forward bias and collector based junction also forward bias. When both the junctions are forward bias, then you can say that your transistor is in saturation region. When emitter junction is forward bias, collector junction reverse bias, it is known as forward active region. When both are forward bias, it is known as saturation region. When both are reverse bias, it is known as cutoff region, and opposite of that is known as reverse saturation region. So what they are saying, condition for which transistor? NPN transistor. Okay, so let me draw one NPN transistor. This is N, this is P, this is N. This is one NPN transistor. The emitter current is outward, and second is PNP transistor. Okay. What first question is saying? The first question is saying VCB is positive. Means this is C and this is B. VCB is positive. If VCB is positive, and okay, this is N, this value is P, this value is N. For NPN transistor, if VCB is positive means N is positive and P is negative. This will make junction reverse bias, and reverse bias junction will, for reverse bias junction, our requirement is not reverse bias second junction. We want it forward bias. So this cannot be true option. And emitter junction forward bias, but we want collector junction reverse bias. But here collector junction is also, we want collector junction forward bias, emitter junction forward bias. But here emitter junction is forward bias, but collector junction is reverse bias. So this is the idea of forward active region. Second, VCB is positive for PNP transistor. Let's say this is PNP transistor. PNP transistor. So VCB, we want this junction to be forward bias. So this junction is forward bias, fine. Emitter junction is reverse bias. No, we want emitter junction also forward bias. Third, VCB is positive, emitter junction is forward bias. Thus, this is the condition for saturation region. Always remember, emitter junction for forward biasing of emitter junction is most important in this transistor. So if emitter junction is forward bias, then only transistor can enter into two regions. The first one is known as saturation region or active region. So C option is correct here. Let's go to the next question. What next question says? Next question says that in a differential amplifier, the differential voltage gain and common mode voltage gain. Okay, the differential voltage gain is 48 dB. Common mode voltage gain is known as 2 dB. These datas are given. Then we are interested in CMRR. What is CMRR? CMRR, common mode rejection ratio. It is ability of a differential amplifier to reject the common signal, to reject the noise. And for ideal differential amplifier, CMRR must be infinity. But anyways, differential gain, the ratio of differential gain divided by common mode gain. Or in dB, or CMRR in dB, it is 20 log of AD minus ECM. This is CMRR in dB. dB is also known as decibels. So what is value of AD? This can be written as 20 log of AD minus 20 log of ACM. All values are given in dB. So this is 48 dB. This is minus 2 dB. This value is dB. These values are given in dB. So what is answer? CMRR is 46 dB. So 46 dB is correct answer here. 46 dB is okay. Don't try to divide this. 48 divided by 2 is 24. 24 is not correct answer. Keep this thing in mind that the numbers are given, datas are given in decibel. This decibel, deci means 10, bel matlab means unit of this. Let's go to the next question. What next question says? The condition for sustained oscillation in RC phase shift oscillator. RC phase shift oscillator is, you are having 3 RC stages. Let me draw it. In RC phase shift oscillator, in RC phase shift oscillator, there are 3 RC stages and every stage provides a phase shift of 60 degrees. So you will use here one inverting amplifier. This inverting amplifier can be any, either op-amp based inverting amplifier or common emitter or common source. You can use any amplifier, and for this, this is the condition for sustained oscillation. You have to remember, you have to remember it because you cannot derive in exam. So H of Fe beta minimum equal to 4 RC divided by R plus 23 plus 29 RC divided by R. RC phase shift oscillator is a positive feedback circuit. Remaining information I can give: a positive feedback circuit with sustained oscillation for Bar-Kasson criteria. Mod of A beta equal to 1, where beta is the feedback factor and angle of A beta equal to multiple of 2 pi. This is Bar-Kasson criteria for sustained oscillation, but we cannot derive it in exam, or because this is just formula, you have to remember it. Let's go to the next question. Which of the following does not have negative, which of the following does not have negative resistance characteristics? So tunnel diode, of course, this is the characteristics of tunnel diode. Yes, it do have negative. UJT, of course. SCR, of course. The FET, field effect transistor, is just semiconductor and it is positive temperature coefficient. So third option is correct here. Let's go to the next question. What next question says? Which of the following ideal characteristics of operational amplifier? Which of the following is ideal characteristics of operational amplifier? So this is my operational amplifier. This is one operational amplifier. This is one operational amplifier. I am giving you complete information about this operational amplifier, what these terminals are known as. Keep one thing in mind, and these are two outputs. So write here some important points of operational amplifier, ideal operational amplifier. These points are very important to remember. Okay. These are the useful terminals of operational amplifier. What it says, this terminal with positive sign is known as non-inverting terminal. This terminal is known as non-inverting terminal. The second terminal here is known as inverting terminal. These are dual supply, so this is VCC and minus VCC. VCC and minus VCC are the maximum output this op-amp can have. So V out maximum, minimum means output cannot go beyond VCC and minus of VCC. Output is fixed. The maximum positive output you can have from this circuit is plus VCC and minimum output is minus VCC. For ideal op-amp, the gain of this amplifier is known as open loop gain. So what is output? Output is known as the potential at V plus terminal, the potential at V minus terminal. So keep one thing in mind, ideal op-amp is an ideal differential amplifier. The first thing is ideal op-amp is an ideal differential amplifier, and for all ideal differential amplifier, what is CMRR? CMRR equal to infinity. Ideal differential amplifier will not entertain common mode signal, will reject the common mode. What is input resistance for ideal op-amp? Input resistance is infinite. What is output resistance? Output resistance of is 0. These are all characteristics of an ideal amplifier. What is next? Bandwidth. What is bandwidth for ideal? Bandwidth is infinity. What is meaning of having infinity bandwidth? Infinity bandwidth means it can entertain any frequency signal. For ideal op-amp it can, because for a practical op-amp there is a limitation on the frequency of this op-amp. But yes, here for ideal op-amp bandwidth is also infinity. What is the voltage gain? The voltage gain is also infinity. Open loop voltage gain is also infinity. So for ideal op-amp, input resistance infinite, output resistance 0, AV equal to infinity, input resistance infinite, output AV equal to infinity, and bandwidth equal to infinity. Okay, so which option is correct here? The C option is correct here. So you can say C option is correct here. Let's go to the next. For 555 oscillator circuit, which of the following pins are connected? I think 2 and 6. This is again theory based question. You have to aware about this. Again, the voltage gain of a tuned amplifier. Tuned amplifier means this is having this type of characteristics. Means one amplifier which amplifies a narrow frequency range, and for this the gain must be maximum. Keep this thing in mind. A very narrow, we want, as we know that gain into bandwidth product is constant, so if bandwidth is low you can have high gain. So what is the answer for this? Maximum. Kirchhoff's law states that this is the basic equation. What it says, what is the statement of Kirchhoff's law? And what Kirchhoff's law says? Kirchhoff's law says that sum of voltage around a closed path is equivalent to 0. Summation of voltage inside a closed path equal to 0. This is Kirchhoff's voltage law. And what Kirchhoff's current law? Kirchhoff's current law says that sum of current at a node is equivalent to 0. Sum of current at any node is equivalent to 0. So sum of voltage around a loop is equivalent to 0 is correct. Sum of voltage around a node, there is no law. Sum of current entering at a node is equivalent to 0. No, this is also wrong statement. Sum of voltage entering at a node, this is also wrong. So which option is correct here? Sum of voltages inside a closed loop is always equivalent to 0 is Kirchhoff's voltage law. And sum of current at a node is equivalent to 0 is known as Kirchhoff's voltage law, and this is Kirchhoff's current law. Okay, one question is based on some basic KVL, KCL. So let me redraw this network and let's analyze what it says. You are having this. Let me redraw the network. A 10 volt battery is there. Then we are having 2 ohm resistance. Then we are having 12 ohm resistance. Then we are having 24 ohm resistance. What this question is saying, the current through 24 ohm resistance. Okay, let's draw the current for 24 ohm resistance. I can convert this into, I can take this node as my reference node. What is parallel of 24 and 12? 12 into 24 divided by 36. 12 3s are 36. This is 8. So this parallel combination is 8. 8 plus 2, 10. 10 by 10 equal to what? So you can say here the current will be 10 volt and this is 10 ohm. 10 volt by 10 ohm. The current here coming from the source is 1 ampere. What is coming? Current coming from the source? Current coming from the source is 1 ampere. Means this source is drawing how much current? This current is equivalent to 1 ampere. Now I can distribute the current into parallel resistance. What the law? This law says the current in 24 ohm resistance is equivalent to 1 ampere into the current distribution. What current distribution says? 12 divided by 24. 12 divided by 24 plus 12. So 1 ampere, and this value is 12 divided by 36, 1 by 3. So 1 by 3 current will go here and remaining current 2 by 3 ampere current will go in 12 ohm resistance. So what is the answer? 1 by 3. 1 by 3 is what? 0.33 ampere is correct answer for this question. A option is correct for the given question. I hope you have understood. This is the basic current distribution. Okay, the current in I3 circuit, a circuit is given and they are asking some labeled current. What this says, this current is I3, this current is 5 ampere, this current is 2 ampere. I can apply a Kirchhoff's voltage law here. When you look at this question, just apply the Kirchhoff voltage law. What Kirchhoff voltage law says? Kirchhoff voltage law says that sum of current at a node equal to 0. So let's apply, let me call this node as a node X. So can I say apply KCL at node X. I am applying KCL at node X. I am applying KCL at node X, and what it says, sum of incoming current is equivalent to what it says. It says sum of incoming current is equivalent to summation of outgoing current. What is incoming current? The incoming current means net current which is incoming to the node. So 5 ampere current is incoming current. There are 3 branches connected to this. So 5 ampere is incoming current, and what is outgoing current? Outgoing current is 2 ampere current which is going away from the node, and another one is I3 current. So let me write I3 is another current. So what is value of I3? I3 is 5 minus 2. 5 minus 2 is equivalent to what? 3 ampere. So what is the value of I3? This is 3 ampere. 3 ampere is correct answer here. Let's go to the next. They are asking at resonance. What is the condition of resonance? The condition of resonance that you are having the least resistance and maximum current. So at resonance, what is the idea? At resonance, the voltage across capacitor is greater than voltage across inductor, or less than voltage across inductor, or greater than or equal to or equal to. We know that if this is my resonance network, the impedance is given by Z times of R plus XL minus XC whole square. This is the idea of impedance. Now, suppose I want at resonance, we know that XL is equivalent to XC. If XL is equivalent to XC, we can say VL is equivalent to VC. The voltage across capacitor is same as voltage across inductor. So this is the condition of resonance. So which option is correct here? Equal to. The voltage across capacitor is same as the voltage across inductor. If I draw this, if I need to draw this is R. And let me say this is one inductor. If this is VC, this is VL, we want VC equal to VL. This is the idea. Superposition theorem. So what is superposition theorem? Superposition theorem says that if you in a linear bilateral network, if you consider only one source active at a given time, then combined response can be summation of all the sources which are available in the network. So the superposition is a generalized theorem. It is applicable on all linear network. There is no differentiation on whether it is voltage source or current source. So this applicable on voltage source only? No. Voltage source and current source applicable on both. This is not correct. Only is not correct. Both voltage and current source, voltage, current and power source. So it is applicable to all. Superposition theorem is applicable on all voltage source, all current source or power sources. There is no problem in doing that. The next question is, if the Q of the coil is increased, then power factor. As we know that the power factor is inversely proportional to power factor. So if Q increase, power factor will decrease. Next. In a distributed capacitance, the inductance parameter of a lossless transmission line is 20 microfarad per meter. So it is given as C equal to 20 microfarad per meter, and L equal to given as 80 microfarad per meter. These are two data given. The value of intrinsic impedance. Okay, tell me what is intrinsic impedance? Z0 equal to under root of R plus iota omega L G plus iota omega C, where G is that leakage current of capacitor and C is capacitance. Okay. For lossless transmission line, as we know the condition of lossless transmission line, for all lossless transmission line, R is equivalent to G is equivalent to 0. So what is the value of Z0? Z0 value is under root of L by C. What is the value of L? The value of L is given as 80 into 10 raised to the power minus 6 divided by 20 into 10 raised to the power minus 6. So answer is equivalent to what? 4 ohm. So 4 ohm is correct option here. So this is 4 ohm. 4 ohm is correct answer for this given transmission line. This question is distributed net capacitance, and this all question based on transmission line. This question is based on what? This question is based on transmission line. Let's go to the next question. What next question says? Okay, the next question is this. A closed loop system has negative gain margin. The system is, always remember, for a stable system, for closed loop stable system, we want gain margin and phase margin both should be positive. If we want a closed loop stable system, gain margin and phase margin both should be positive, or the phase crossover frequency should be greater than gain crossover frequency. These are conditions for a stable system. This is the condition for a stable system. So omega PC is greater than omega GC. So what they are saying, negative gain margin means unstable system. So which option is correct? Unstable system is correct. If gain margin or phase margin, anything is negative, the system is said to be, this is question based on control system. So this is negative. Let's go to the next one. What next question is saying? Amplitude modulated signal is given. As you know that how amplitude modulated signal looks like. The amplitude modulated signal looks like this. Amplitude modulated signal looks like this. This is envelope. And we want one more thing, which is carrier. So this is the carrier. This yellow part is known as carrier and this white part is known as envelope. Here this yellow white part is known as envelope or message signal. This yellow part is known as carrier signal. And what is modulation index? Modulation index or depth of modulation. So this value is known as V maximum. The maximum value of envelope. And minimum value of envelope is known as V minimum. So in this two voltages, in terms of two voltages, we can define the modulation index mu equal to V maximum minus of V minimum divided by V maximum plus V minimum. So both the values are given. What is V maximum? 5.9 volt. So this is 5.9 minus 1.2 divided by 5.9 plus 1 by 2. So 6.9, 7.1. And this value is, okay, no sir, not 7.1. This value is 0.9 minus 2 is 7. 5 minus 1 is 4. 4.7 divided by 7.1. And that value, you can calculate that value. It is less than 0.5. Okay, less than 0.5, only one option is correct here. 0.662. Okay, 4 by 7. Okay, you can calculate this. It is 0.667, correct answer. 5.9, 1.2. Okay, this is the idea. Okay, so let's go to the next question. Which of the following indirect method for FM generation? As we know that the frequency modulated signal can be generated in two ways, the direct FM generation and indirect FM generation. FM generation can be divided into two parts. Direct FM generation, indirect FM generation. FM generation can be divided into two parts, direct FM generation and indirect FM generation is process of generating narrowband FM first, then use some frequency multiplier. Some use frequency multiplier and it will generate wideband FM. And in this we use high frequency oscillators with varactor diode. So Colpit-Hartley, this oscillator, high frequency oscillator generates using direct band FM. So varactor diode modulation, Armstrong modulation, reactance modulator, reactive FM modulator. Which one is correct? The technique is known as Armstrong technique. Armstrong technique is the idea of converting narrowband FM into wideband FM. This is known as Armstrong method. Is a technique which converts, first it generates narrowband FM. Narrowband FM means this del F equal to 25 Hertz frequency deviation, and using frequency multiplier we use maximum deviation of 75 kilohertz with the help of frequency multipliers. Let's go to the next question. What next question says? A broadcast radio transmitter radiates 20 kilowatt, means it can radiate, the total power it can radiate is 20 kilowatt. The percentage of modulation means eta equal to, or let me write mu equal to 0.6. 60% modulation is there. What will be the carrier power? As we know, for AM signal, amplitude modulated signal, the total power of amplitude modulated signal is given by PT equal to, total power is equivalent to carrier power plus 1 plus mu square divided by 2. This is the idea. So what is total power? 20 kilowatt is equivalent to PC 1 plus 0.6 square divided by 2. So this is PC 20 kilowatt divided by 1 plus 0.6 square divided by 2. And you will calculate this, the answer will be 16.94. So majority of the power is carrier power in amplitude modulation. Okay, the propagation by means of space wave occurs. Yes, it's a very high frequency theoretical database question. Next, again formula based, the ionospheric region, the N, the maximum number of electron density is equivalent to what? It is 9 under root of N. Keep this thing in mind. It's a formula direct. I cannot derive here. Next, the bandwidth of PCM, N into FM, depend on sampling. B option is correct. Greater than, higher the sampling rate, it is higher the bandwidth. In a delta modulator, what is delta modulator? Delta modulator is a 1-bit quantizer. Delta modulator also known as one bit quantizer. Delta modulator is a quantizer. Quantizer is something which converts a discrete samples into codes. So what is slope overloading? Suppose in delta modulator you are having one message which is very fast in variation, having fast variation. Then what delta modulator says that you are not able to catch it. Why you are not able to catch it? Because this step size is less. So suppose you want to catch this message, you have to catch the step size. So what I can say, by increasing the step size, by increasing the step size, you can remove this error. This error is known as slope overloading because the slope of message is overloaded. And what we want to say that message is fast varying and the delta modulator is slow varying. That's why not able to catch. So what is the idea? The slope of signal must be greater than or equal to, slope of signal must be less than or equal to del, this is step size divided by ts, slope of this staircase waveform. This is idea to avoid the slope overloading in delta modulator, a very special modulator quantizer which converts everything into two levels, or one bit quantizer. One bit quantizer means how many levels? 2 raised to the power 1 levels means 2 levels. Okay. What is one alternate name of amplitude shift keying? A very obvious question. The amplitude shift keying means you are representing data 1 by amplitude 0 and data 0 by amplitude A. So suppose you are having bit of stream 10 11 001, then what you will say? You will transmit 0 here, then you will transmit A here, then you will transmit 20, then 2A, then 0. So this is known as on, this is known as off. So what is name of this modulation scheme? This is known as on-off modulation scheme, passband communication, digital communication modulation scheme. So keep this thing in mind. Let's go to the next. This is amplitude shift keying. So amplitude modulation is what? Amplitude modulation is an analog modulation scheme. Amplitude keying, phase shift keying is your passband communication scheme. What is the horizontal radiation pattern of dipole antenna? So keep one thing in mind. The horizontal radiation pattern of dipole antenna is this. In spherical coordinate system, this is given by the figure of 8. Next, the gain of isotropic antenna. What is gain of isotropic antenna? The gain of isotropic antenna is 0, no directive gain. The gain of isotropic antenna is 0. Isotropic antenna, one which radiates equal in all the direction. Next, the relationship between antenna gain and effective area. So you know that it is solid angle G equal to 4 pi divided by lambda square into effective area. So I think this option is correct. G, again formula based question. It says that the relationship between antenna gain and directive effective area, and that is G equal to 4 pi divided by lambda square divided into AE. Okay. In magnetron, again in microwave, the oscillations are produced due to the bunching of electron. So only radial electric field is there axial electric field is there, radial electric field. As we know that in magnetron operation, the radial electric field is radial, and magnetic field is axial. As we know, again theory based question. Principal operation of klystron. How klystron magnifies the signal, amplifies the signal, and what is the idea? Idea is very popular, known as velocity modulation. A constant beam of electron. In this beam of electron, there is a sinusoidal small signal. So this will accelerate the signal. This will neutral velocity. This will retard the electron, and it forms a beam. That is amplification. So this technique is known as velocity modulation technique. Okay. So this is part one. This is part one of Telangana State Council paper for higher studies, and all the questions I have explained with the little bit of theory. We cannot go into the detail. Just we are revising the concept. That's why one word answer for all these questions. I hope you have understood it. Thank you very much.